do I need to consider? I need to consider other things. Recordings in progress. So we're going to learning objectives. We're going to obtain a better understanding of how the mineral composition and formation of stone allows us to work with those stones in different environments. We're going to learn about the science of each species of stone, how it's quarried. We're going to look at some quarries, different types of quarries. That's going to be indicative of sometimes the cost of the stone, how we get it, where we get it from, how it's mined or quarried. We're going to talk a little bit about fabrication and what stones are easier to work with and what stones are tougher to work with and why we choose those. And then at the end, there's a resource list that we're going to talk about to get the answers that we really need when we're speccing these things at the different levels, whether you're a designer or an architect, or you're in charge of the master specification, or you're an engineer. There's 3 modules of the course. Pay attention. If you feel like participating, at the end of each module, I'm going to ask a few questions. You can feel free to unmute yourself and jump in and answer the question, or maybe we should just have you type it in the chat. We'll wait for your answer there. That's what we'll do. So otherwise, everybody could be commenting at once. So that's a glass half full approach to the participation in the CEU. At one time, we used to give these in person, right? We could look at each other in the eye and hand out stones, and you guys could feel them and understand what the differences are. And we still are able to give these in person. So if you're at a firm and you want this for your team and you want to see samples of stones, we'd be happy to set that up. Or if you just want product presentations too, feel free to reach out. So let us jump to module 1. What is a natural stone? A natural stone is a stone that's been harvested from its place in the earth and maintained without being broken down. An engineered product which has been processed into small particles, a fake stone, a faux stone, where we take the dust or concrete or anything else that has to do with the earth, break it down and put it back together, is not a natural stone. Even it may be 90% natural stone or marble dust and mixed with an epoxy or a resin to maintain a shape, but it's not a natural stone. So a stone that is harvested from its place in the earth, and we've fabricated edges, corners, but we haven't broken down the actual matrix of the stone. In layman's terms, if I take a banana, it's a banana, a piece of fruit. If I blend it up in a smoothie, it's no longer a piece of fruit. Here is a travertine being harvested, a big block. You can see the airbags are actually pushing this thing out. You can see the sediment layers in the stone, and it's actually being separated across down through the veins, but you can also see when it hits the ground that it actually cracks with the grains as well. Just an important thing to notice when we're talking about the structure of stone and how stones are constructed and how we cut them and utilize them for different products. So I just point that out. It's cool. You can see how big the block is. Those aren't tiny men. They're actually life size. We're going to talk about 2 mineral types of stone. And on this earth, there are 2 mineral types of stone. There's calcareous stones made up with calcium carbonate, and there's siliceous stones made up of silica or silicates. So there's 3 basic formations of stones. There's a sedimentary, there's metamorphic, and there's igneous. So I'm going to go back. I'm not going to go back. There's 2 mineral types of stone, calcareous and siliceous. And then we'll cover the benefits, the features, and things to watch out for in each of those 2 mineral types. And then we're going to cover the formations of stones, the 3 different types of stones and how they are linked to calcareous and siliceous. A sedimentary formation is simply that, stone that is formed over time with pressure, sediment layering over and over and over again. If you think as a kid, after a rainstorm, you're riding your bike and there was a puddle that dried up, and the dirt or the mud actually had layers and started to peel back in the heat of the sun, that's just an early formation of sediment. And as things land on top of it, press it down over time, you'll find that that's where our sedimentary stone comes from. This happens to be the water, the pressure, the river runoff, and everything that goes with it. So whether it's dirt, soil, whether it's sea life, seashells, anything, eggshells, human remains, bones from animals, over time, that can, you'll find those in the sediment. This is a sedimentary formation. This happens to be a travertine sedimentary formation. And travertine is formed a lot of times with the precipitates runoff from rivers and lakes. And this is what we're seeing here. A metamorphic formation is not unlike a sedimentary formation, and then it starts with layers. But when we add heat to the situation, the rock starts to metamorphosize and actually change the dynamics of the sedimentary stone to give it actually other features that we can work with when we're talking about what those stones are. So while they're similar, they have sediment layers. A metamorphic stone has other features that are available. So we add the heat and the pressure, and we slow cook something that's a little bit different than the sedimentary rock. And then finally, the igneous formation is really the Earth's gift of taking the stones, any stone, melting it down, and creating a new stone. So the igneous formations can most often come from the volcanic eruptions. They can have an intrusive cooling and an extrusive cooling. It means they cool in the ground, or they cool above the ground. And this chart breaks down all three of those types of stones and how they are linked to the mineral types of stone. So an example of a calcareous sedimentary stone is limestone, travertine, and onyx. A calcareous metamorphic is marble. And a calcareous igneous doesn't exist. So anything that's been blown out of the volcano or cooled under the ground from a molten lava doesn't have any calcareous base. In contrary, siliceous sandstone is a sedimentary siliceous. It has no calcium in it, but still has layers. Metamorphic, similar. Slate, quartzite, serpentine, and soapstone. We'll talk about those and some applications on those stones in a little bit. And then there is siliceous igneous, which is granite and basalt. Very dense, very durable, and usable rocks in a lot of situations. Some of the defining characteristics when we're considering using stones, natural stones, for our application. Some things that may limit what you do with the stone: absorption, density, compressive strength, abrasion resistance and hardness, flexural strength, and modules of rupture. Absorption has to do with the porosity of a stone. And as we look, I have a couple different presentations here. Think of this as a cubic foot of limestone, and it has pores that absorb water. And when water gets in there, especially in a freeze-thaw climate, it can expand, contract, it can blow apart the stone, it can rupture the stone. So the denser the stone, a lot of times the more durable the stone. That doesn't necessarily mean that a dense stone is the most abrasion resistant stone or the most chemical resistant stone just because it's dense. Now, to illustrate what the density does to the stones with the porosity, you can think of a cubic foot of limestone as weighing about 140 pounds per cubic foot. Take that same cubic foot of granite, and it weighs about 180 pounds. So much denser, heavier, less spaces within the cubic foot of the stone. So the density and the absorption kind of work together. The compressive strength and slate, while it seems like a sedimentary stone, is really a metamorphic stone. So for example, the compressive strength of slate, if you were going to run trucks across it outside, may or may not be the best application for that stone. It's the ability to withstand pressure from the top. So that's important to understand, and understanding what the applications are. How much weight, what's that going to take? In many industrial environments, manufacturing facilities, they use very dense stones like granites to be the base for precise machinery and stamping equipment, and measuring too, because they can make them extremely level, and they're extremely stable and don't give. They're more durable than concrete. Abrasion resistance and hardness are important. From is this going to scratch if I put this? Is it going to show wear? And what does the hardness mean? Flexural strength, really when we're talking about stones, L over 360 is a term that we use in the tile industry to talk about 360 inches, allowing for 1 inch of movement up and down without any cracking or degradation to the product. Well, sometimes with stone, those flexurals of strength, L over 480, 480 inches, 1 inch of movement in and out, and L over 720 on some stones are just as important on the walls, because stones, depending on how thick we cut them or how we hang them, become more fragile. So the flexurals of strength is an important term. And the modules of rupture, most commonly used with marbles, some of the water sensitive marbles in exterior applications can change and rupture or bend or curl. Other stones can blow apart too. In an ASTM test for freeze thaw, they actually soak a stone in water and they freeze thaw until it blows apart, and we're able to give it a rating on whether it's ASTM tested for freeze thaw sustainability. So one of the most common misconceptions about stone is the harder it is, the more durable it is. Well, it depends on the application. Now, taking in consideration that soapstone is a number 1 on this Mohs scale, and diamonds would be a number 10, 10 being the hardest, 1 being the softest. Diamonds versus talc are the baselines for this. We're able to put our stones in here and give it a hardness test. Something to think about when we're talking about the hardness of a Mohs scale. Rarely do we have a pure stone where it is completely granite or completely limestone. They have other minerals in there. So to take a knife blade that has a 5.5, 5.5 Mohs scale hardness rating and run it across a stone, it's not giving us a true indication, because there may be other elements in that stone that say, hey, well, while the basalt in this is a 5, the quartzite's a 6, but it also has some other products and other things in here that make it softer. So this is a great baseline. It's a great thing to understand, but it's not the be all end all when selecting your stone. You can see here that sandstone has a very high Mohs hardness scale compared to its counterparts, but for example, a light commercial rating with a honed finish in a commercial application on a floor can scratch. And I'm telling you that because I've lived through it, and the expectations of that stone didn't live up to what the architect wanted when he specified that in a apartment complex lobby. And we wound up with scratches and wound up with some hurt feelings because it didn't perform like he wanted to. So always great to ask, how is this going to perform in the environment? Given our druthers, we probably would have said, hey, that's not the product for you. We'd rather not have the sale and have a relationship going forward. So Ask your folks. Granite, on the other hand, in the floor as pavers, much more resistant to scratching, even though it's a little bit lower on the Mohs scale. So quartzite, very, very durable product used for countertops, floors, inside, outside, pavers, very resistant to scratching. So just because it's harder doesn't mean it's best. And my final example of this is a soapstone or a serpentine stone, very soft, but a lot of times used in laboratory environments where they use chemicals. And they're very chemically resistant because of their makeup. They don't have very much calcium, but they're very soft, so they can get scratches in them. Because they're soft, people use them for countertops. They're also very fixable. So it's very, all the different characteristics of stone are really indicative to each stone, and having a partner that helps you through those, is this good for what I want to do it for, and setting those expectations is important. So that's module 1. And I think maybe really the most important module, understanding that it's tough to understand and be an expert. So align yourself with people that can get you the answers that you want. And the Natural Stone Institute is part of that as well. So are quartz surfacing materials considered natural stone? And feel free to type in yes or no. And Mark Durkee says no, and he's right. And if we were in person, I'd throw you a t-shirt. But good job, Mark. Quartz materials, anything broken down from its in situation is not a natural stone. Even though it may be durable, it may have a lot of the performance characteristics, it's not a natural stone. What are 2 types of mineral composition on stone? Anyone? Yeah, Lauren Foster. I would have thrown her a candy bar. She would be enjoying that right now. Thanks, Lauren. Silicious and calcareous. And finally, what are the 3 types of rock formations? That's 3 words. I understand it. Oh, there it is, Emily. Emily Bush with the igneous, sedimentary, and metamorphic answer. That's great. Thanks. And then I would have thrown you a gift certificate to Starbucks for $50 had we been in person. When we look at the chart, an example of each. Sedimentary would be a limestone, travertine, and onyx in a calcareous sedimentary. Remember, the metamorphic calcareous is a marble, and there's no igneous calcareous rock. And then the siliceous sedimentary was a sandstone. The metamorphic was slate, quartzite, serpentine, and sandstone. And granite and basalt were igneous, siliceous. And I think it's best to look at the chart real quick. I'm a visual learner, and there's your examples of your stones for your recap. Okay, let's talk about natural stone types. So as we go a little bit deeper into this chart that we just looked at, we're going to talk about calcareous sedimentary limestone. And this is a product from Mother Earth that I'm having a hard time with my chat. You can't see it, but it's over my slide. A sedimentary rock consisting chiefly of the mineral calcite with or without magnesium carbonate. Now, a limestone can be a dolomite limestone, or it can be a oolite limestone. So the calcium magnesium carbonate is in the dolomite limestone. Because it's calcareous, limestone is not as durable in a lot of applications, but because we're able to, it's so readily available and it's so beautiful and it does perform well outside. This happens to be a limestone quarry. This one is in Portugal. You can look at the size of that block that's harvested. Limestone contains a lot of fossils, shells. It's got calcite streaks or spots, pit holes. It can have iron in it. I just was at IU dropping off one of my kids at college, and I was walking around the campus. And Indiana University is known for its Indiana limestone and the quarries there, and all the buildings on campus are made from that. But these 150-year-old buildings and 100-year-old buildings actually have rust coming out of the limestone that's embedded in there, the mineral composites and deposits over time, and they work their way out with the water. So all those things that Mother Nature puts in there leads us back to the conversation about the Mohs scale. What's the hardness of limestone? Well, there's different things in there, and there's different limestones. So it's always important to ask. Sometimes limestones are affected by acid rain over hundreds of years. We can see that in older buildings, how they're changed and how they change in color and weather with time. But all in all, they stand the test of time. We're able to shape limestone, cut it, use not just it as a building block, but we're able to do it with columns and wonderful features. Here it is on a countertop. Because remember, we talked about limestone and its porosity. People use them on countertops. They're beautiful. And it really depends on what your expectation is. So if you're not going to treat it and maintain it, limestone can stain. It can soak things up. And in Europe, a lot of places, they just accept that. They use limestone because of the cost and the locality of the stone. And they accept the stains and the wear and the absorption in the product as a patina, and that's okay. In the United States, some homeowners are more picky, and they don't want their product to change over time. And those patina, things that are considered a patina in Europe are considered a stain or a defect over time. So setting those expectations, maybe limestone wasn't the right product for that person on the countertop. But you can see in the side cut on this that it's got fossils and striations, just a whole lot of movement and beauty. Another way to bring out the beauty in limestone too is with an enhancer or a sealer or polish it, and you're able to see those, and you can actually have two stones in one. And we see that done a lot of times too, to achieve the look, even darken the stone as well. Here are limestones hung on a building, large slabs. It works exteriorly, and understanding what the limestone's flexural strength is, sometimes limestone and where it's harvested from, can lead us to how we're going to hang that, whether it's kerfs or dowels and things like that. So if you're an engineer on the call, it's important to understand that limestone has the proper hanging based on the composition of that stone. And it can be accomplished. You just have to find out where that stone came from and how it's going to perform. This happens to be the Buff Dolomitic Limestone Pinnacle Award winner from 2013. A finely crystalline, massive deposit of calcium carbonate of white, tan, or cream color. And what we're talking about here is travertine. And we talked about a little bit earlier how the precipitates from river or running water leaving the minerals over time give us that travertine. Hot springs are known for that as well. This was a travertine block that we looked at before with the airbags. We can see here that the split coming across the stone with the grains, because it's sedimentary-like, broke, but it also broke down through there as well. The travertine is stronger one way than the other. Not all rocks are that way. I'm going to throw a term out there. Isotropic, which means it's stronger one way than it is the other. So important. We'll talk a little bit more in depth about that. And there's isotropic, which means, and generally that is for products that are igneous, that have been formed, and we can cut them either way because and they're equally strong, and we don't have to really be conscious of that. Travertine has pronounced anisotropic properties, which includes holes. So commonly used because of its beauty as a flooring product, used on walls because of the veining, the depth, the no two pieces being the same. When it's used on a floor application, a lot of times it's filled, and it can be filled with an epoxy or a cementitious fill to fill those holes. Something like a high heel shoe can go in one of these holes, and even if it's filled, pop that fill with a break-in period over time with travertine and the movement that it has. But a beautiful product utilized all the time. Here's some examples of it outside, vertically and horizontally on an exterior application with a ledgestone paver type stack, and on the ground as well with large format tiles. And here it is on the inside, a walnut travertine, and you can look at the different color variations and just how unique and beautiful that is. It really sets apart from the faux stones and the fake stones and a lot of the other products that people put on fireplaces. Here it is with actually a raked finish. So it gives it a beautiful consistency. And they made the check-in counters out of the product as well. Oh, no questions. Calcareous sedimentary stone. Another example of that is onyx, and a compact cryptocrystalline, generally translucent variety of calcite, usually deposited in cold water solutions, often in the form of stalactites and stalagmites in caves. Once again, a runoff with minerals, sedimentary stone. This is what it looks like when it's harvested. Why we love this stone so much is because it has a beautiful, and often it's used in hospitality, casinos, because after it's finished, it has this wonderful translucent feel to it that you can backlight. You can cut it very thin. You can use it for stair risers. Some of the things you don't want to use it for are on the floor. You don't want to use it in applications where it's going to get wear. It's not very durable, and if it's got direct wear on it. But here it is in a flurry cut, and here it is in a vein cut. And a flurry cut would be across the top. Some people call that a bed face cut. And a vein cut is down the front, kind of like split face. We've just cut the front of your book off. That if your book or magazine, you put the bind against the wall, and we just take that first inch and we cut that off. We've just done a vein cut. Here's some onyx, backlit, beautiful. I was involved in a project in the Detroit casino probably 13, 14 years ago, where there was large onyx backlit down the hallways of the Detroit casino when they built it. It was beautiful. And actually understanding how it functions and installs, that the installer did a wonderful job, and it still looks beautiful to this day. Marble is a calcareous metamorphic rock. So a calcareous metamorphic rock means it's been pressurized over time, but it has calcium in it. So it may have some limitation as far as applications. It would be susceptible to chemical attack, and it can be acceptable. Marble can be acceptable to water sensitivity depending on the species or where the marble comes from. So it's important to ask, is my marble water sensitive? Can I put it outside? And a lot of marbles we can put outside vertically. We'd never put them on the ground. Sometimes in freeze thaw climates, some marbles can be a victim of what's called hysterosis, was where the water gets in there and freezes and actually changes the makeup of the marble. And when it moves due to that phenomenon, it will actually delaminate from its place, or uncouple itself or start to work itself free because it's actually changed. So understanding where to use marble, is great. Here's a marble quarry, a white Carrara marble. White Carrara is one of the easiest marbles to work with, and we'll talk a little bit about that later on in the presentation. It's a very deep quarry, probably the most famous named marble, white Carrara. Highly prized for its steady values, relatively uniform in crystal. But folks love marble on countertops. There is maintenance that goes with that, but just understanding what that maintenance is in the process. And there's sealers and companies that actually offer warranties with their products to do the maintenance. So if that's the look that the client wants, there's products that actually go over to save them over time. Here's a Emperador light Turkish brown marble. People a lot of times just think of marble as white, but we can get in those brown and beige colorways too. This is a wonderful Calcutta marble, floor tiles, subway tiles on the walls with a beveled edge, in a shower. It can work in wet environments, inside. So that's module 2. Can you name a calcareous stone from each of the following categories? So a calcareous stone that is sedimentary, and we just looked at that chart again a second ago. Let me pull up my chat. If you're typing in your answers, give me a second. Oh, no answers. All right. A calcareous sedimentary stone, limestone, travertine, and onyx. A metamorphic calcareous stone is marble. And there are no igneous calcareous stones. So that was a trick question. What are some common applications for the following types of calcareous stone? Limestone is wonderful residentially and commercially. We can use it outside, inside, vertically. Inside, we can use it horizontally on the floors, tiles, stones. Outside, in certain applications, it can be used vertically, but you may want to consider what that application is. Travertine is not unlike the limestone in its applications, exterior, interior, vertical. We see a lot of residential, horizontal. Onyx, hospitality, vertical, can be sustainable to wear in chemical attacks, and even with cleaning products. A lot of times it's important to understand that. And then marble, wonderful product. We use it inside, outside, outside sparingly, depending on the marble. Important to ask if I can do that, if that's what you want to do. Siliceous sedimentary stone, sandstone, a classic sedimentary rock composed of grains, sand size 1/16 millimeter to 2 millimeter, set in matrix of silt or clay, united by cementing the material, commonly silica or iron oxide, calcium carbonate. The sand particles are commonly quartz, and quartz is very durable. Quartzite stones are very durable. Here we're harvesting sandstone in place. There's a guy underneath the crane, so that's a nice big piece of sandstone. He's actually coming in through the sedimentary layers and pulling that out. This is a red rock out of Colorado. Sandstone is wonderful to give us a natural finish. Our company's actually associated with the sandstone, that we actually use the sandstone finish because it's so unique and uncommon, unduplicatable from piece to piece. And when we actually put it in tiles and then take those tiles and do different things with them aesthetically for interior projects. Generally, it's more porous than other dimensional stone, but naturally, even though it's more porous, it has an abrasive non-slip surface. And it's resistant to chemical and salt deterioration too, which means outside, we can use it in a lot of places and have a very durable installation that's sustainable. Here's a wonderful sandstone application on some columns. Here it is outside as a flagstone type installation. Here it is honed and run vertically as well as on columns. Serpentine is a siliceous metamorphic rock, which means it has silicas in it, and it's been formed under sedimentary heat and pressure. It really, we'd know it as a rock that has a greasy luster. It almost looks like it's wet or oily when we look at it. Here's a quarry in Vermont. Look how deep that is. So because of the mining process, sometimes the deeper we go, the more expensive it is. It's no different than the farther we have to travel with stone. Sometimes the more expensive that is as well. And this is what it looks like. You'll see fibers and almost a fibrous finish sometimes. That, remember, this has a very soft rating according to the Mohs scale, but it has a very durable, it's used in countertops, it's used in laboratory settings because of its chemical resistance, because if you scratched it or gouged it, you can fix it. We can do wonderful things with the edges residentially. That's kind of cool. And then there's some pictures coming forward. Here it is run exteriorly on columns. So it performs well outside. And then soapstone is very close to serpentine stone. And here's a soapstone quarry in Virginia. Here it is oiled and unoiled. The oil, some people will treat their countertops every 6 months. Some people will treat them every year. Some people are more attention to the details, and you may see them do more than that on a maintenance regimen. But what it does is it gives it a wonderful luster, maintains it. Soapstone has a high heat retention, which allows us to use it in, once again, laboratory settings, as well as fireplace surrounds and things like that. The green iron soapstone on the left is a nice example of the fibrous nature that some soapstones can have. Tanya, I'm not seeing the different examples of sandstone. All right, Tanya, we'll shoot you some examples after the presentation. I'm writing down your name right now. Sorry, I missed your chat earlier. Look at the edge on this soapstone counter. So pretty cool. And so you're able to fabricate that. It has a very inconsistent consistency. Looks pretty cool. Slate, a siliceous metamorphic rock formed from shale deposits. Here is slate being harvested. A lot of times it's easier to harvest. However, because the way slate is formed, it's tougher to get larger sheets. Somebody may like, I love the way that looks, but I want sheets that are 4 by 8. Sometimes the very nature of nature and how it's formed limit us in how big we can actually make those sheets. Slate has anisotropic properties, which means it's much stronger one way than it is the other. So if we cut, I'm going to go back, it's stronger this way than if we were to cut it across the edge of the magazine or the book. If we put the binder up against the wall, cut those pages off, it doesn't have as much strength and can cleave or separate. Has a nice finish, not unlike sandstone naturally when we split those across those sediment layers. This is a nice combination of slate and limestone put together horizontally. Tiles honed, actually polished. You can see the reflection right there. Slate is wonderful inside on the floor, is very durable. Outside, sometimes over time, water, wear, and water collecting in it can separate that. So not always the best choice horizontally outside. Quartzite is a very, very durable silicious metamorphic rock. It's got quartzite in it. It's metamorphic. It's dense. It's silicious. So chemical attacks, salts. We love all our quartzite products from a durability standpoint, and many times from an aesthetic standpoint too. It's hard to beat what they look like. And in many applications, white quartzite matches up with white limestone, and they work together very well for horizontal and vertical applications on exteriors. So combining different stones that work well together, complement each other, is a fun thing to do. This is a quartzite quarry in Nevada. We can see the sedimentary layers. Quartzite breaks across the grain, not around the grain. So if it broke around the grain, it would be more apt to fracture. It's a very durable material, withstands weathering well. There's a mixed quartzite floor tile and a blue quartzite countertop. This just came up with somebody I was talking to earlier today. We were talking about polished versus honed. When you can see a mirrored reflection like this bowl in this, we know it's polished. When we can see an image or a shape, but we don't actually get the mirrored image, we're going to get a reflection, a reflective property, that's going to be honed. Sometimes that can be tough to tell sometimes with some of the tiles and stones with a honed finish versus a polished finish. The honed finish lends itself to better slip resistance as well. Here's a quartzite on a countertop, works well in that environment. Yeah, works well with sober people as well as drunks. So a lot of chemicals and cleaning solutions, and acids and things like that, that in those commercial environments, it just wears great and looks good too. Basalt is a silicious igneous stone, and has a composition similar to gabbro. Let's just show you a few pictures. This is cooled above surface, and it actually forms, if you look down at these columns down here, almost in large crystal forms. This is a basalt quarry in China, and you can see it almost has an octagon type shape, and they're harvested off the wall that way. Not in blocks, but in those shapes. So it's great for wet environments because it's so dense. It's highly abrasion resistant compared to marble or limestone. And here's some basalt in some water features outside as stair treads, pavers, just a wonderful looking product. Sometimes basalt and granite can be confused commercially. Or gneiss, a lot of times, is a name that's tossed around. So understanding what it's called and understanding composition can be important. But most importantly, will it work in my environment? Here it is on the walls and the floors in two different formats or cuts. Silicious igneous stone number 2 is granite. Here's a granite step quarry in South Dakota. And at first glance, you think it's kind of small, but then you look down here at the equipment at the bottom of the picture and you understand the scope and the scale of this quarry. Granite has high abrasion resistance, high densities, chemical weathering resistance. You can cut it almost any way and have the same strength properties. The importance of that is, and we'll show in some pictures coming up, is you can do fun things with the graining and the veining and the different layers. So isotropic means that we can cut it any way and have almost the same strength capabilities, compression strength, and things like that. Using it as pavers is wonderful. We can give it a flame finish that gives it a highly resistant, slip resistant paver finish. There it is used outside, and it wears as well as anything. It can be used in kitchen applications because of the density. Backsplashes, countertops. That happens to be a polished granite. Outside, of course, monuments, it's used, tombstones. And that's module number 3. So can you name a silicious stone from each of the following categories? A silicious sedimentary stone is a sandstone. A silicious metamorphic stone is a slate, a quartzite, a serpentine, and a sandstone, or excuse me, a serpentine or a soapstone. And then a igneous silicious stone is granite and basalt. So remember, silicious are highly resistant to chemical attacks because there's no calcium in there. So that's your lineup there. All right, so knowing your stone. All stones are very unique, as we talked about today. I've been ambiguously vague, and but giving you some resources to understand different stone properties and what we do. Properties may vary even within one type of stone. Always identify the specific material to ensure its application is appropriate. Perception of color will vary depending on orientation, lighting, surrounding, materials, even sealing it, cleaning materials, the perception of what's going on there. So when we look at these stones, some people will go, hey, that product on the left is a marble. Some people would call it a quartzite. It's actually a quartzite by makeup, but commercially sometimes it's known as a marble. The one in the middle, is that a granite or a gabbro? And it's hard to look at that, it just looks like a black box. You didn't put anything in there. That actually is a gabbro, but commercially referred to it as a granite because of its performance properties. And the last one is a gneiss or a granite. Well, it's nice, but commercially referred to it as a granite because it performs as a granite too. This is a booked match cut. So we've gone across the veining of the same block, and then we've turned it end to end. Kind of cool. So if I was able to fold that in the middle, like a book, I would just take the right and fold it over the left. That's where we cut it, and then we just open it up, just like a magazine or a book on the floor. Being able to do that allows us to do this. And because the veinings change as you move through the block, you can get a book match set, which no book match set on this wall is exactly the same. Kind of like rings on a tree stump. So we're doing veining, we're diamond matching this, and then we're using the other cuts for the stairs and the tread and the floor for just a very unique, one-of-a-kind application. This is called a slip match, where we've taken the graining of the stone and we've run it next to each other on the floors and on the walls. If you look close, and if you're watching on this computer, it may be hard to see, and I'm speaking from experience on this one too, the expectations of the veining and how they move up and down, and I think there's one coming forward, we can see that the veining can move so drastically up and down that the expectation for mock-ups a lot of times needs to comply with the harvested stone if it's a large project. And what I mean by that is you can do a mock-up with existing samples, but having the harvested stone match the mock-up is very important for customer satisfaction. You don't want to have the veining change, as it can, the deeper we go in a quarry, or have movement to it. Sometimes the customer only wants a certain amount of movement with the veining. They want it to be completely horizontal, and that's not always the case. Or they may be not understand that the color range. Look at the variation in this. This is probably a V4 with range. You've got dark pieces and light pieces, and we can see dark pieces together if we really analyze this. And maybe we would have laid those out and mixed them. So there's, I would call this a beautiful installation, but somebody may say, why are those dark pieces right there? It's just with natural stone, setting the expectation and understanding, even the mock-up and the selection versus what actually shows up on the job site. Signing that back piece with your name and your date, giving that to your supplier, and seeing what the product looks like before it's even shipped. Hey, I'd like to see that, match it up. Is there a sample that we can do? This is a nice example. We've referenced it a couple times. How am I doing on time? Oh, geez, 3 minutes. Flurry cut through the bed. It's also called a bed cut. And you can see we're just splitting that off through the sediment layers, and then a vein cut across the face of that. In the veneer stone industry, we call that a split face cut. Polish, tone, and what that does to the smooth finish and the aesthetic of the stone. Here's a sandblasted finish, an acid wash finish. Those create wonderful exterior and non-slip treads, as well as a brush. Now, sometimes a brush can actually make it smoother depending on the type of brush finish that you're going for. So it's a brush finish doesn't always necessarily mean a slip resistant. Tumbled. Here's a brushed and chiseled. Here's a sandblasted and brushed. We saw deep cleft line cut on an earlier slide on a hotel lobby, and then flame finishes, really a go-to for exteriors for non-resistant in lobbies and commercial applications outside for non-slip finish. Sometimes inside a flame finish is a little bit tougher because it's so rough that it becomes a cleaning issue. So split face is we've just taken that stone off the front of the mountain, just like Mother Nature left it. Bush hammered, it's just mechanically abrading that finish to that finish right there, beating it. Here are some of our standards and organizations: ASTM, ANSI, the Natural Stone Institute, there's the Natural Stone Council, the TCNA, as worlds collide with Division 9 and Division 4, the finishes, but all these resources are important. And then design resources as well, whether you're a fabricator or you need to get in touch with somebody. But a great jumping point is with your natural stone vendor or partner, or you probably have many, and the Natural Stone Institute is a great place to go directly as well. Okay, that concludes the presentation. Once again, if you didn't fill out the CEU, or if you did register through that, we'll get you your certificates here shortly. In the meantime, I'm going to stop sharing my screen. Thank you all for joining us. I know we're at the top of the hour, and if you have a few minutes, I'm just going to take you to I'm going to take you to our realstonesystems.com page. Realstonesystems.com is a company that started out as a veneer stone company, and we've spread our wings. I need to share my video one more time. And thanks for staying on. If you are staying on, and if you've got to go, I get it. In my slideshow, pull up my Realstone. So this is realstonesystems.com is the website. in addition to stones, and you see a lot of the stones that we talked about on the front page or during the presentation on our splash page, from basalts to granites to quartzites to slates. We also not only do those in veneer stones, but we also do natural glass. We talked a little bit about sandstone. This is a wonderful project. This blue is actually a sandstone that we take because each piece is different and it's finish and unique. And we put it in a subway tile shape that allows for a herringbone design or a running bond or a brick pattern. And we give it pigments and foils and wonderful things. We have limestones that are installed in pools, as here, for exterior applications, as well as different tiles. So as you go through here, we have architect resources, designer resources, BIM, hatch patterns, and things like that. If you'd like to know more, have a in-person or virtual product presentation, we'd love to do that for you. But I wanted to give you information to our website. As you take your time and peruse through here, you'll find many different products that people didn't know we had. And so take some time to do that. And I'm always available. I'm in charge of sales for the United States. Rajna was on today. She's in charge of our marketing. So whether it's social media or the weekly and bi-weekly updates and project features that we have, she does heads up the team for that wonderful work as well. So if there's no questions, let's see, it looks like there might be a question. All right, yes, Emma, you are able to get a PDF version of the PowerPoint. Oh, you had to step away. Yeah, so Emma, after you complete going through the PowerPoint yourself, then we'll send you your certificate. No, I'm just joking. We will clearly get this to you right after. So I'm writing your name down. We owe Tanya some images on Sandstone, and Emma, we're going to get you a copy of the PDF version. Garage will help with that, so it doesn't take up as much space. No problem. Haha, she laughed. All right, I wasn't sure. I get no feedback on these things. We have other CEUs coming up. Please stay tuned. In 2 weeks, we're going to have thin stone veneer, the basics, an important installation to show us and talk about panelized stone, thin stone veneer, how you can incorporate that into your installations inside and out, installation methods for that for great success. And that's going to be presented by Linda Wood, who manages our Rocky Mountain region. And so we look forward to that. We've got some more on the docket coming up that are going to be put on by the Natural Stone Institute. We've got a paver one coming up for commercial paver systems and residential, rooftop and outside. That's coming up at September as well. So we're glad you're here. We appreciate your time, your business, and we're willing to give you as much help as you want. So feel free to reach out. Everybody have a great day, and thank you very much.
Thanks, Kevin.